So it's 1 o'clock. I thought, or it's 1:30. I thought we'd get started while everyone's still filtering in. Thank you all for joining the panel. The impact of unmanned maritime systems on Indo-Pacific navies. I'm George Galderisi, Director of Strategic Assessments Technical Futures at Naval Information Warfare Center Pacific. Our center has a huge stake in unmanned and AI and machine learning, so I'm privileged and happy to moderate this panel. Before we get rolling, I'd like to thank AFCEA National, particularly Terry Rogers and AFCEA Hawaii for giving us an opportunity to share our views. And I'd have to say that AFCEA is prescient because the way they stacked the presentations today with Admiral Ruttenberg and Dr. Sterling, those lead right into our panel, and so we couldn't have had a better warm-up. So what do we intend to cover today? Our panel is the impact of unmanned maritime systems on Indo-Pacific navies, and this has helped to shine a light to get over some of what Dr. Stralin said, the hype that surrounds unmanned systems. So while it occurred a half a world away, the events in Ukraine, where the Ukrainian military used unmanned surface vessels to attack the Russian Navy, we think that's a harbinger of the future, and we wanted to leverage that in our remarks today. So many navies in the Indo-Pacific area are already using unmanned systems with their militaries for a lot of reasons. Number one, they help lessen the risk to humans. They deliver persistent surveillance over areas of interest, and they provide options to warfighters that inherit with unmanned systems. And from the United States perspective, and really focused directly on this panel, the U.S. Navy's Force Design 2045 envisions a future of 350 crewed vessels and 150 uncrewed vessels. And this is embodied in Force Design and the Navy's Unmanned Campaign Plan. Unfortunately, it's a little opaque as far as just what those unmanned systems are intended to do, what missions. And there are a lot of aspirational goals out there, but not a lot of specifics. So that's why we're talking with you today. So we've assembled a panel of subject matter experts: Mr. Neil Zerbe, Dr. Jamie Lukos, and Dr. Jeffrey Watmull from OceanNet, who will address this issue. You have their bios in your conference app, but I just wanted to hit the high points here. And immediately to my right, we'll start off with Neil Zerbe. Neil Zerbe is a career naval aviator with extensive experience in the F-14 Tomcat. He didn't teach Tom Cruise how to fly the Tomcat, but he would have if he was asked. He has extensive staff experience in multiple fleets, and more importantly for this panel, he's an industry consultant and a subject matter expert in unmanned systems. So a fun fact that you may not know about Neil, that as a lieutenant embarked in one of our carriers with an F-14 squadron, he was voluntold to escort a number of sailors to a complimentary Don Ho show right here at the Hilton Hawaiian Village. And as Don Ho always did, he wandered through the audience, he saw Neil in uniform, he saw his pilot's wings, and Don Ho had been an Air Force pilot, so they immediately bonded. One thing led to the next, and just so you know, Neil's not shy. Soon he was singing on stage with Don Ho right here in the Hilton Hawaiian Village. So please join me in welcoming Neil Zerbe.
If it won't offend anybody, I'm just going to stay here and read my remarks. I have a lot of high points I want to get in. George knows if I go to PowerPoint, I start to tell stories that go beyond the chart. George asked me to focus on experimentation, so since my singing career did not flourish beyond being a sailor interviewed on the Don Ho show, here's some more background so you can get a feel for my being a panelist and my perspective. During my active duty career, I was a trained, certified, designated as a Tomahawk land attack missile planner. I ended up executing over 200 TLAM missions during Desert Storm and at my stint at U.S. Central Command. While these were one-way missions, it was the early years of unmanned systems, and during my third fleet years, we instantiated fleet battle experiments, now known as Trident Warriors, and did extensive experimentation with the earliest of unmanned systems. When I left active duty, as George was telling you, nobody cared about how many thousands of hours I had in the F-14 or how many carrier landings I had, They were glommed onto my unmanned systems experience and understanding the C6 ISR that's required to support such systems. So with that as background to preface that, for the last 20 years in industry, I've been heavily engaged in the unmanned systems domain. My company, Aerospace and Defense Industry Partner, helps companies find the new, innovative, emerging technologies right interested parties. That might be operational end users, science advisors, warfare development centers, or other industry partners. We're engaged in the development of unmanned systems. Our frustration, industry, is with the deliberate processes that prevent expedited capability to the fleet. My remarks that follow will be as an industry guy outside of DoD looking in, as an industry partner desiring to support DoD. RIMPAC and Trident Warrior 2022 was the major coming out for USVs operating with the fleet. As a result, the integrated battle problems are increasingly pressing USVs in broader and more intense set of missions. The Warfare Development Centers, UWDC, NAUTIC, SCHMIDT, are emerging as lead entities that support industry partners in working new innovative emerging technology into fleet experimentation. Down under, the Aussies have conducted autonomous warrior exercises to expand the use of USVs with their manned fleet. In Autonomous Warrior 2022, Australia, New Zealand, UK, and US participated with 30 autonomous systems. Maritime Tactical Systems is a company that had both a Mantis, which is a 12-foot and smaller electric USV, and Devil Ray, much larger fossil fuel powered USV in the mix. Specifically, MARTAC demonstrated the capability of the Devil Ray, a 50-foot USV with speeds well over 50 knots, carrying smaller USVs, the Mantis, to launch in remote operating areas. Similar exercises and experiments are ongoing in NATO, Atlantic, Indian Ocean, and Baltic. I'm going to focus more today on the Pacific. These exercise and experiment initiatives are critical to leverage if navies are going to convince their governing leadership they have a well-wrung-out plan for unmanned systems. This effort of showing versus telling has gained significant ground in convincing government that funding for unmanned systems is a logical path to future manned and unmanned teaming. It's the intrinsic value of experimentation. On the NIMEO side, use of USVs have been identified as the optimal tool to manage and mitigate illegal, unreported, unregulated fishing. USVs can be positioned around the EEZs, the exclusive territorial fishing zones, and alert a vessel is entering the EEZ and report it to the right interested parties 24/7, 365. IUUF is a mushrooming issue globally. This is literally the playground bully stealing other countries' lunch money. You may notice I reference an industry partner USV leader both in commercial and DoD domain, Maritime Tactical Systems. They have worked extensively with 5th Fleet CTF 59, you heard Admiral Ruttenberg mention that this morning, on a myriad of missions. In the Indo-PACOM AOR, MARTAC efforts go back to Trident Warrior 2016, where they did some of the earliest work with respect to port harbor security. For example, the Oiler, designated the high-value unit, that transited between Pearl Harbor and the RIMPAC fleet was escorted by a Mantis USV at the Pearl Harbor entry buoy. The USV was dropped in the water, did a once around the hull for the security check, escorted the HVU to the pier. While the Oiler was reloaded, the Mantis demonstrated the capability to provide 24/7 patrol around the pier. When the HVU departed to return to the RIMPAC fleet, the Mantis escorted her out of the harbor and to the buoy. The HVU retrieved the Mantis and stored her aboard until she returned to Pearl Harbor and dropped her in the water to repeat the process. I have copies of many of those missions, 11 missions specifically, that were demonstrated in RIMPAC 2016 if you're interested later at a sidebar. Alas, as happens in large bureaucratic entities, much of this experimentation success faded into documentation buried somewhere under the Pentagon. I am amazed at how these things get rediscovered as a new idea years later. As an industry partner, some gracefully refer to me as a graybeard, I am frustrated with this constant rediscovering of the wheel. The previous CNO established Unmanned Systems Task Force, and they are an ongoing work in progress. an intense effort to expedite USVs to the fleet. When they engage with industry, Autonomous Unmanned Vehicles, Systems International, etc., we are able to provide them with past performance that many of them are discovering for the first time. As an example of the increased fleet USV focus, at an Unmanned Systems West event held in San Diego in September, the Commodore from the Surface Development Squadron 1 briefed the Phantom Legion lines of effort. That is the CONOPS that is being developed for naval surface forces using USVs. It's coming. So there is some encouragement with rediscovering lessons learned. MARTAC has been heavily engaged in the 5th Fleet Unmanned Systems operational test and evaluation. Granted, it is the CENTCOM AOR, but again, as the Admiral said this morning, most of the missions being OT&E'd there are exactly what Indo-PACOM is seeking. To that end, PAC Fleet Integrated Battle Problems, PACOM AOR exercises continue to use Mantis and Devil Ray's USVs. Missions range from OTH ISR as an unattended, semi-autonomous vehicle to become a loyal wingman to demonstrate a capability to be a precision weapon, like a TLAM, on a one-way kinetic mission. And as George mentioned, think about the use of the USVs in the Black Sea and Sevastopol against Russian naval vessels and infrastructure. My observations from the industry side are that industry needs to crisp up its savvy and be aware of those entities on the DoD side seeking to advance unmanned systems. DoD are busy folks with everything going on in the world and high seas. As a former numbered fleet warfighter ACOS, I recall my daily tasking and was woefully unaware of the broad spectrum of technology industry had or could develop to solve problems. This is where things like Trident Warrior come in to support migration of technology to the fleet, bringing new technology and to experiment with and how it can be used is a great way to grow awareness among the DoD end users. One of the best venues for experimentation is done in the Eastern Pacific at the NSWC Port Hueneme Division. They do an annual Antex called Coastal Trident and is very broad in nature and wide open to industry. Bring it and experiment with it. They are co-located with NSWC Port Hueneme Division is EXWIC, the Engineering Experimental Warfare Center. They provide USV assessment of industry technology to help fill port harbor security gaps. Coastal Trident efforts include Navy, Marine Corps, first responders, FBI, BLM, Coast Guard, and other industry partners seeking that killer app for their program of records. As an example, the Port of Long Beach experimented with a Mantis USV to help provide 24/7 patrol at the Port of Long Beach. Coastal Trident does the preponderance of experiments in the Pacific and very specifically in the Port Hueneme AOR. That said, as we speak, they are experimenting with the technology in Kaneohe Bay that produces energy from wave motion and then plugs into USVs and UUVs that need a recharge and a comms pipe to dump their collected data. Past Trident Warriors have underscored the value of USVs in the mine warfare domain, both offensive and defensive. In Trident Warrior 2020, a Devil Ray USV carried a smaller USV and a UUV on a RoRo deck, hauled them at speed to the area of concern, offloaded the USVs, the UUV, to detect and then destroy mines, recovered them, and returned to home base. Similarly, Devil Ray was used to haul mines to an area of interest and plant those mines with precision. In another major PACOM AOR experiment, DoD executed a very large expeditionary effort. Most of us remember it as S2ME2, but it was ship-to-shore maneuver, exploration, and experimentation. This was conducted on the beaches of Camp Pendleton. Using MARTAC and as example, a Mantis USV was launched from a ship offshore to go recce the Del Mar boat basin. The USV entered and departed the basin, gathered ISR data, and was undetected. The DoD Physical Security Enterprise and Analysis Group, PSAG, often uses experiments to do their analysis of unmanned systems. In 2017, they experimented with the MOTS, Military Operation Terminal System at the Pacific West Coast facility at Concord Army Complex. Most of us remember that as the legacy Naval Weapons Station Concord with the large Port Chicago Naval magazine. My experience there was with Mantis, and the USVs were used to meet and do security screening of arriving cargo ships, then escort them to the pier. While the ships were being loaded and unloaded, Mantis patrolled and kept the traffic away from the MOTS. This was a particularly interesting one because the Sacramento River empties into the San Francisco Bay, and there are dozens of commercial ships going to ports upriver and hundreds of pleasure boats around. So this was an interesting experiment. The Mantis provided escort to the boats that got too close, provided the 24/7 eyes on HVU that normally required 2 manned Coast Guard patrol boats to provide security 24/7, 365 when it was at the pier. Finally, at Valiant Shield, the experimentation focused around unmanned logistics. A Mantis USV was launched from a USNS well off the coast of Guam, loaded with supplies, transited at high speed to the shore, dumped its load, and brought retrograde back to the USNS. At the end of the day, unmanned systems are force multipliers and loyal wingmen to the fleet. The most recent former CNO identified the deficiency of enough hulls to support Navy operational needs worldwide and specifically called out unmanned systems as a technology to fill that gap. The current CNO was the ESG commander during a bold alligator exercise in the late 2010s. She observed firsthand the work that Mantis USVs could do and became a quick believer in them as a force multiplier. Those are some of my thoughts on the growth, past, present, future of unmanned systems. Oh, hold it. This just in. A Navy press release released this morning talks about an operational test and evaluation that happened. It actually happened on the 26th of October in the Straits of Hormuz, but it was just made public in the last 24 hours. During exercise Digital Talon, a Martac Devil Ray USV launched lethal miniature aerial missiles. Every missile was a direct hit. Those are some of my thoughts on the growth, and happy to have sidebars, questions, whatever comes my way.
Okay. Thank you, Neil. Okay, next up is Dr. Jamie Lukos. Dr. Lukos is the Senior Technological, Cognitive, and Decision Science subject matter expert at Indo-Pacific. In this role, she leads the center's strategic partnerships in the area of cognitive research and decision-making. She received her doctorate from the Arizona State University, where she worked with neural control of movement laboratory and studying human decision-making in unpredictable settings, a lot of the things that you heard during the luncheon speech. A fun fact about Dr. Lukos is that to help pay for her doctoral studies at Arizona State, she was a beer vendor at many Phoenix sporting events, and she found that running up and down stairs yelling "beer here" was fun and a great stress reliever. So please help me and join me in welcoming Dr. Jamie Lukos.
Thanks, George. And thanks, Neil, for that opening. I don't know if I can compete with that. I didn't write anything down, but I will try. So my background's in neuroscience. I study humans, which is the opposite of unmanned systems in a lot of ways, but I think there's a lot of overlap there and a lot of important elements of studying human decision-making that will enable our unmanned systems to actually function out in the field. So I guess just for a little bit of background, as George mentioned, I went to ASU. I studied grasping for my dissertation, actually, so trying to figure out how, I can just lift up this cup without any thought about it, with never seeing it before. I don't crush it. I don't throw it over my head. But how do these 5 interdependent agents on my hand with hundreds of inputs and outputs, how does that work together seamlessly to function? And so I've used that in the way I approach how humans interact in complex environments and how humans interact with complex systems. How do we work together as an interdependent system, as a unit, to make sure that we're coming to a collective decision on what should be the right way to complete a mission. So I work at NIWC Pacific, so Naval Information Warfare Center Pacific, headquartered out in San Diego, California. But we do have awesome facilities out here, obviously in Hawaii too. There's about 400 of us out here as well. So unmanned systems is a huge part of information warfare. So prior to the role I'm in now, I was the Battle Space Awareness Business Portfolio Manager. And so that had a lot of the unmanned systems work that we do in that portfolio. And the way we like to describe it is not necessarily building the systems, so we don't create the platforms necessarily, but we make them smarter and we make them better. So it's all about the intelligence that goes into those systems. So I can talk at length about that as well, but I thought it might be a more unorthodox perspective than to focus on the human instead, and how when we talk about our Indo-Pacific navies, we're talking about our platforms, of course, and there's a lot of brilliant people making our technology, but we really have to think about the human element of our navies as well. And what does projecting this distributed network of sensors, of platforms, how does that affect what our warfighters need to do? So we talk a lot about computing on the edge, about how we can't bring the data back to make a decision. We have to make a decision right there and then. We don't have the time, we don't have the bandwidth, we don't have the ability to send it back. So that changes the way, that fundamentally changes the way we have to make decisions out in the water. So that's sort of the perspective that I'm trying to bring to this new position that I'm in, as George mentioned. So it's a senior technologist for cognitive and decision science. How do we make sure that the decisions that we're making out there with our new technologies are actually allowing us to have decision advantage against our adversaries? Because we can bring in all the technologies in the world, but we really, really have to understand what we're doing with that information and ensure that that's giving us an advantage and not just increasing the fog of war, right? We want to make sure that, yes, we're injecting a lot more and there's a lot of confusion now in the environment, but we want to be able to control and understand that confusion better than our adversaries. Let's see, what else did I write down? I think that's the majority of it. The other part, I guess, one more thing, is we're not going to win, obviously, by bringing more manpower to the fight, right? And so understanding that the people that we do have making those decisions is also a critical component of the human-machine teaming element of this, and how well our unmanned systems are going to work is let's really understand our people, whether that's measuring them, really kind of taking the behaviors, and my background's more in neurophysiology. We could even, understand them from that perspective, understanding state changes, because we all know that, in terms of the systems that we have, our humans, our warfighters, are the most unpredictable, and but they're also the most consequential, right? So how can we understand them better in this more holistic human-machine team arena? So those are the kind of questions I'm trying to answer, and our team at NIWC Pacific is trying to answer. So with that, I'll hand it back to George.
Thank you, Jamie. So finally batting cleanup is Dr. Jeffrey Wadamo, who is the AI lead at Oceanit right here in Hawaii, a company well known for creating disruptive technology from fundamental science. His research is centered on achieving optimum mathematical results in human cognition. He received his doctorate in artificial intelligence from the Massachusetts Institute of Technology. A fun fact about Jeffrey is that he played the protagonist in 4 of Shakespeare's 5 great tragedies and the antagonist in the 5th. And I'm certain he would like to let you know which was which when we open it up for the Q&A. He also has a New York Times article he co-authored with other experts in this field, which we'll leave up on the table here, and you're welcome to grab. So over to you.
Right. Many thanks. So, as they say in Monty Python, now for something completely different. So, by training and temperament, I'm a mathematician and philosopher, And philosophers, mathematicians, theoretical physicists, we seek solutions to problems first by abstracting away from complexity. That is, we idealize the phenomenon. So, simple formal systems in mathematics, frictionless planes in physics, etc. In philosophy, we conduct thought experiments, or deiknomy in the ancient Greek. From Galileo's falling bodies or Schrodinger's cat, these imaginal experiments are designed to isolate and illuminate the essential variables at play. With unmanned surface vehicles, the ideal thought experiment is that of a fully autonomous system, so the limiting case. And then once we understand the philosophy in that extreme case, we can then begin to understand the intermediate cases between that singularity and where we are today. So first we ask, why this philosophical methodology? Because only philosophy studies at the fundamental level what there is, how we can know it, and what ought we to do about it and how to go about it. Ontology, epistemology, and ethics, in other words. Furthermore, only philosophy, particularly the style of philosophy we practice at Ocean at my company, only this style has formulated mathematical theories of ontology, epistemology, and ethics. And this is critically important in the case of artificial intelligence, of AI, the kind of intelligence that must enter into the operation of any unmanned surface vehicle, whatever its degree of autonomy. So, because ask, what is AI fundamentally? It is a computer program. What is a computer program? It is a theory. It is a theory written in a computable notation. It is a theory of the phenomenon it computes. So, for instance, a good old-fashioned computer chess program encodes a theory or a repertoire of theories of chess. For an artificial general intelligence, an AGI, the kind of intelligence we can imagine powering a fully autonomous unmanned surface vehicle, we need a theory of general intelligence. Now, such a theory does not exist for the most popular fashion of AI today, so-called generative AI, the species of AI powering large language models like GPT, which are examples of so-called foundational models in machine learning. The fact that an explicit theory of intelligence does not exist for generative AI is not seen, ironically or perversely, it's not seen as a failing by its creators. It is seen, I said, ironically, perversely, as its cardinal virtue, the key ingredient in its open secret sauce. Foundation models are based on deep learning neural networks whose power derives not from any theory within the system, but from data without. So for instance, some years ago, Google DeepMind claimed that its deep learning system had mastered the game of Go without human knowledge. So like David Hume and the empiricists in the 17th century, or B.F. Skinner and the behaviorists in the 20th century, deep learning presumes that, in Google's words, reward is enough, that general intelligence and all its applications in specific domains can be reduced to the maximization of objective functions. Specify the objective function exactly, so make the move that will increase the probability of winning this game of Go, say, and the AI, or the AGI, will behave exactly as intended. It is believed that this is the solution to the so-called control problem, the problem of aligning AI with our interests in the science fiction becomes science fact scenario now of an autonomous AI, such that it will not go rogue like HAL, the AGI in 2001: Space Odyssey. Ironically, that brilliant film, I think, demonstrates the fundamentally flawed philosophy of machine learning. In the film, we're not told why HAL went rogue, but as philosophically attuned film critics, we can infer that his exquisitely exact objective functions were contradictory, and that HAL, or any AI so designed, lacked the philosophy, the theory of knowledge necessary to resolve the conflict. It could not transcend its objective functions and create new objectives as a normal human would. We humans can jump outside of the system, or jutes, as we say at Oceanet, into the imaginal, and from a meta level, consider counterfactuals or possible worlds, reflect upon and criticize the past that subsists in the present which exists, and on which the future insists. Now, I know this sounds as abstruse as a philosophy of film seminar, which is why at Oceanet, the company, we style ourselves as a mind-to-market company, in that we transform these abstruse, abstract philosophical ideas into concrete and commercializable technologies that can be deployed by, amongst others, the military. And this is why we are working to endow AI with the human capacity to jutes, transcending the limitations of machine learning. So it's ultimately to create anthronoetic, which is our neologism for human-level, human-style general intelligence, that which would be necessary for autonomous AI, including autonomous surface vehicles. So autonomy, as embodied in human minds, means creative decision-making. Questions of autonomy are therefore inherently moral questions, the stuff of ethics and philosophy. Indeed, at Oceanet, we define morality quite simply. Morality is a kind of decision procedure for navigating the space of possible actions, which includes inferences, statements, movements, etc. So morality is the problem of what to do next and why. In other words, superimposed upon the physical landscape through which your autonomous surface vehicle navigates is a moral landscape. To navigate the former, the AI aboard the vehicle needs to answer what questions. What is the situation? But to navigate the latter, the moral landscape, it must answer why questions. Why ought I to do this and not that? Now, if any of you ever enjoyed or endured Philosophy 101, you'll have been taught or have been preached the dogma that you cannot derive an ought from an is. That is, nothing about the way the world is determines how it ought to be. Descriptive statements do not entail prescriptive statements. Facts and values are non-overlapping metaphysical magisteria. This dogma, universally believed, is false, I submit. And its falsity is the reason moral intelligence in humans and the future autonomous AI we create in our image is possible. So at OceanNet, we've worked with ONR and now with DARPA on creating a moral grammar for autonomous AI. We mean a grammar here in the Chomskyan sense. A generative grammar for language is a recursive function or a Turing machine that enumerates all and only the grammatical sentences of the language. Analogously and identically mathematically speaking, a generative grammar for morality is a recursive function that enumerates all and only the ethical actions of the morality. A grammar is therefore a decision procedure. Like the decidable problems of arithmetic for a Turing machine, sentences and actions are the decidable problems for a grammar. The moral grammar we're creating would enable an autonomous AI, and someday an AGI potentially, to decide, given what it thinks is the case, what it ought to do, and to explain why. The critical capacity here is, we think, enabled by linguistic competence, using language, literally using language to construct sentences with modal verbs. We conjecture counterfactuals, imagine possible worlds. We imagine how the world in this case could be, how it ought to be, which by our actions then transform the way the world is. And thus we invert the logic. We derive an is from an ought, and is therefore an aesthetic process. Artificial intelligence should be an artful intelligence. And we've demonstrated this with our anthronoetic AI, whose name is GNOME, the noetic mathematical engine. And one of the first Galilean domains, the idealized microworld, architected to exhibit the essential aspects of our AI's mind, in which GNOME operated. This was an idealized strategy game, essentially a complexified form of battleship, say. This is an interesting test case because unlike Go and chess, this game is not one of complete information with some arbitrary goal. GNOME is given a partially revealed board state and must, by its process of critical rationalism, discover the true state of the board. What GNOME ultimately seeks is an explanation for the configuration of the partially revealed game board. Why does the board appear this way and not that way? The reason why, the explanation, is the complete configuration, the position of the hidden surface vehicles and submarines. And this is not a trivial technical divertisement with no generalizability. It is an exercise in explanatory causal model construction, and GNOME's decisions are based on a moral grammar. And now, to conclude, with DARPA, we are developing this grammar by encoding the fundamental principles and procedures that enable humans to generate an infinite number of moral judgments, analogous to the infinite number of grammaticality judgments we can generate given our genetically encoded linguistic grammar. This poses profound philosophical questions as to the nature of these principles and procedures. In essence, what moral system should we encode into AI, and how do we encode it? We can discuss this further if you're interested. We can debate if you fancy. I enjoy that. So at a minimum, if AI is to operate aboard something like an unmanned surface vehicle, it must know the laws of war and understand, for instance, the distinction between something like jus in bellum, when to engage, and jus in bello, how to conduct hostilities once engaged. But ultimately, morality transcends any particular ethical decision. It is about the philosophical reasoning that powers such decisions. And that reasoning, we submit, is computed in the medium of language via conjecture and criticism in a Darwinian epistemology. And thus the ultimate moral imperative is to protect and promote that epistemology. Autonomous AI must therefore be a kind of artificial philosopher. If it is not, autonomous AI ought not to be deployed, I would argue. But the views and opinions expressed by your speaker do not reflect those of OceanNet Incorporated.
Yeah, thank you, Jeffrey. I just wanted to take the moderator's prerogative to pile on to what our panelists have said. Who was here this morning for Admiral Ruttenberg's remarks? Okay. So he talked a lot about the integrated battle problems, IBP 23.1, 23.2, and continued 2024. As Jamie could tell you, our lab hosted the Distinguished Visitors Day for IBP 23-1. And for those of you in the military, you know how tightly scripted these things are. And so there are about 24 USVs on display. And for DV Day, each company got to talk with the Admiral and his delegation. And this is tightly scripted. They were told 5 minutes and then shut up, that's all you have. Well, Admiral Paparo led a delegation of more 2 and 3 stars and SESs than you could count. And he stopped at each booth, and the people talking were kept to their 5 minutes. But guess what? He kept asking question after question after question to enhance his knowledge of what the USVs could really do. So I think that just shows you a level of interest and a level of commitment, just like Admiral Ruttenberg touched on this morning. So before I turn it over to you all for Q&A, I wanted to ask the panelists if any of you all want to ask each other a question for clarification, or just turn it over to the crowd.
Since I don't have a PhD after my name, I slept in a Holiday Inn Express last night, and that's where it ends.
Okay, so now that you've heard from our panelists, we wanted to open up the floor to you. Please step up to the mic, identify yourself and your organization, and ask whatever question you have. You can ask a question of a specific panelist or to the panel in general, in which case we'll try to figure out who'll catch that fly ball. And so as a courtesy to others asking questions, because I see there's quite a number of people here, just ask a one-part question, and I'm sure a panelist would appreciate it if you would ask a question and not deliver a manifesto. So with that, as a tee-up, who's got the first question?
Hi, Jim Fabizak, SAIC. I'll do you better. One question, one sentence. What's the future of Project Replicator?
Okay. You want to start out, Neil?
So, good question. Replicator first popped up on my screen, probably 6 months ago during integrated battle problem planning and the like. So my understanding of Replicator is it's a unmanned system, can be any unmanned systems as far as my understanding goes, but it's something that can be replicated, it can be attrited in its mission, and rapidly reinvigorated either in numbers or one for one. That terminology is being used by both the Unmanned Task Force as well as my work with the PACOM and PAC Fleet planners for the integrated battle problems, but that is a key word that's entered the lexicon in the unmanned systems domain.
And just piling onto that, for those of you that happen to watch 60 Minutes about a month ago, it's 60 Minutes overtime, and General Milley, the chairman of the Joint Chiefs of Staff, spoke about unmanned and AI, and he referenced Replicator, and to him, AI is the most important technology that the military's dealt with since nuclear weapons. But thanks for the question. Who's next? Oh man, a shy audience. Yes, sir.
Bill Kearns with Lockheed Martin. So, Dr. Wadamel, thank you. Some interesting ethical, philosophical questions you raised. There have been efforts to examine the role of AI with lethal force. Could you or maybe some of the other panelists talk about that?
So the most difficult decision that any intelligent or unintelligent system must render is the lethal question. So we at OceanNet are not that, and even as an individual, I'm not interested in deciding on the question of how, when to pull the trigger, because I think at that point in the this is an Orwellian term, in the kill chain, at that end, it's a problem of identification. Basically, the morality of taking the shot has been codified. I'm more interested in, and I think what is more important for us to do, is to design the system of morality within which such decisions are ultimately made. So what kind of a person, or what kind of a, so an AI would be a kind of person. So what kind of an AI, what kind of a person takes this particular action in this particular situation? And hence, that's why I refer to endowing the system with knowledge of the laws of war, the rules of engagement, those constraints on the intelligence operating such that if it understands that it is responsible for lethal decisions, it understands the gravity of how to render that decision and when. But ultimately, that moral imperative to protect and promote the means by which to engage in conjecture and criticism, because I think, like Socrates, I think morality is a kind of knowledge. That's why fundamentally the highest priority, and this has been discussed quite a bit of late, I think there were 2 op-eds in the New York Times in the past 2 weeks on how the laws of war should be applied in the Israel-Hamas conflict. That the ultimate priority is to be cognizant of the lives of civilians, because ultimately all laws of war ought to prioritize the minimization of death. And so that would be the kind of AI would seek to exhaust all of the possibilities prior to making that decision.
So one thing.
I could add to that. I would just in terms of, I think it really speaks to the importance of explainable AI and transparency as well. Like, we haven't touched on that much, but just like any human that makes a decision about death, like we better understand the AI component. It's likely going to happen in the future, whether we like it or not. It's going to happen at some point, I would think, and hopefully, like you said, the morality aspects are there. But importantly, we also have to have a basis from which we can explain why our systems are doing what they're doing to ourselves, to our enemies, to the whole world, because it's probably for the first, when it happens initially, it's going to cause a lot of stir. And so I think building the systems appropriately is going to be vital, but also, being able to explain the rationale and every single element of it is just going to be key.
And while Jamie's got the mic, if it's okay, we, NIWC Pacific, partners with AFCEA for an event every year called the Naval Applications of Machine Learning. And if you wonder how people in the field, subject matter experts, actually get together, compare notes, learn best practices, it's that event. So Jamie, could you just give us a couple of sentences on that event?
Yeah, thanks. Great plug, George. Every year I think we're at our 9th or maybe even 10th annual year of the Naval Applications of Machine Learning workshop. So it's usually in the February-March timeframe in San Diego. So it's hard to entice people away from Hawaii, but the rest of the country usually likes to join us in San Diego at that time. And it's growing bigger and bigger every year. It's a lot of industry, academia, and government coming all together to talk about the application space, how mature some of the technologies are, what gaps still exist from a research perspective, and just what can we all do together to ensure that our navies are getting the best technologies moving forward. So I don't have any stickers, sadly. That's one of the important parts of the conference, is a really cool sticker every year. But if you do want to know more, either contact me or I don't know how Googleable it is. Just find me and I'll point you in the right direction.
Great. Anyone else with questions?
How you doing? My name is Kevin Jones with the Department of Defense. With AI and using neuroscience and building out these autonomous vessels or unmanned vessels, how do you ensure the integrity and also the information that you have to make sure that it's secure, that our adversaries can't use it against us?
Okay. Jamie, you want to start out that one?
Sure. Yeah, huge question. The cybersecurity element of it is super important, and then of course layered throughout all of it is this concept of trust, which is an important, very important concept, but also this very nebulous social construct that is difficult to measure and changes all the time across people and across the situations. And so that is a huge part of the whole equation, and one that we're trying to figure out how to deal with it. But as I mentioned a minute ago, I think the transparency element is super important, and ensuring that we're working with the right partners. I'm sure some of you in the audience, to make sure that security is a known thing that we can rely on, and when it's not, ultimately, knowing when it's not to, because of course there is always that chance and likely going to happen that there'll be times where we can't trust our data. So understanding what are the protocols when we don't have the data that we're sure of. We still have to act. We still have to go to war. Then what? So I don't have a good answer for how we do that, but it is absolutely vital.
Thanks, Jamie. Anybody else?
Indeed, it's interesting. I think so. There's interesting convergence there of trust and cybersecurity. So in mathematics, it's interesting that when one proves a theorem, is in essence you're trusting that your inferences have been valid, and how you verify that trust is that it's explainable step by step. You can follow the syllogism. Aristotle showed us how to follow each step to fundamentally believe and trust that the theorem is true, that the inference was valid. And now in cybersecurity, we're beginning to use methods of automated theorem proving. So mathematicians have been using computational methods to assist them with proving theorems. And in cybersecurity, you can adapt and apply and exact those methods to perhaps trust the data that you're receiving, because basically your interlocutor can prove it to you in a mathematical way, prove that the data has not been corrupted, that the identity is correct, and in fact show that if the data has been corrupted, that'll show up basically as a fallacious move in the proof. And then ultimately, the cybersecurity, the cyber system can be as intelligent as an automated or as an artificial mathematician. And even with some of the work we're doing at Oceanet, you can build or subsume this automated theorem prover into a cyber grammar. So in the same way I was talking about a linguistic grammar being able to, the grammar with which you're endowed enables you to understand novel sentences. The moral grammar would enable it to understand novel ethical decisions. With a cyber grammar, it would be a grammar of malware, for instance. So it could recognize a zero-day virus and understand it, even if it had never been trained on these data, because it has the grammar of all possible malware. So you merge mathematics, linguistics, cyber, and you begin to solve many of these problems.
Okay, thank you. Yes, sir.
Yes, Joshua Baghdadi from University of Hawaii Applied Research Lab. So we've been on some emails, Neil, and this question will be directed towards you. You hinted at it momentarily ago, but we have seen a lot of successes come out at the top levels of the Navy from what's happening at NAVCENT and Fifth Fleet, and specifically under their Task Force 59 efforts. You mentioned the Mantis and the Devil Ray vehicles, MARTEC, Ocean Arrow has had some platforms out there, and really made a lot of positive, generated a lot of positive just conversations about the capabilities that unmanned systems have to bring to bear to the fleet. So how do we bring those successes that Task Force 59 has shown us? How do we curate them and adapt them to the Indo-Pacific AOR?
The good news, as I alluded to in my remarks, is that it's happening. Between the Unmanned Task Force and my perception is both PACOM and PAC Fleet are just laser focused on expediting getting those in place. So in the integrated battle problem planning sessions and the like, not only are they taking what CTF 59 has done, they're taking them and adapting them to threats in the Western Pacific. So if you think of the Straits of Hormuz and the work that CTF 59 has done there, PACOM's looking at another set of straits. Little different geography, but a lot of lessons learned from CTF 59 in doing that. But I will tell you, deep in the bowels of the planners and strategic war plan development, they're coding those in.
Yeah, thanks for the question. Just wanted to pile on to what Neil said. Jeffrey's got some handouts that talk about AI up through ChatGPT. And Neil and I, as aviators, he didn't mention his remarks, but we're always interested in how high does it fly, how fast does it go, and all of those attributes. So he's got some handouts that describe some of the USVs that CTF-59 used, what their attributes are as far as speed and range and all those sorts of things, just to put some concrete terms to it. Anyone else with questions? Don't be shy, we're getting near the finish line. Okay, any other remarks from the panel or things you wanted to add on?
Yeah, George, you mentioned Admiral Ruttenberg's comments today, and what a lead-in to this panel. I mean, George and I looked at each other and it's like, well, okay, I guess we show up and take questions now. But one of the things he did foot stomp a little bit is the PACOM, Pac Fleet, AOR mindset, and this touches a little bit on what the doctors talked about, but they're at the semi-autonomous mark. And so in this hot-off-the-press news release, while the USVs carried the capability and the like, the decision to launch them was made back at a headquarters somewhere. There was a human in the loop. And if I heard Admiral Ruttenberg's comments correctly, that's where they are in the mix. The clock is ticking to get to full autonomous, and these guys got to get busy and figure out how we can get there faster. But the PACOM AOR is comfortable at the semi-autonomous level.
Yeah, and I think that also speaks to the whole, like, where should the decision be made? And I think that is changing, and you can also see it in how we're training our military, and that's going to be the key. So, for example, one of the things coming down the pipeline now is a robotics rating for active duty Navy. And so now they're being trained what is AI. That's part of their job. So up until now, they'll do tours as a UUV operator or a USV operator, but then that's it. It's not a career. But now it's changing into a career. And so that changes the way we can approach, the systems and what they know about them and who makes the decisions. Because going back to headquarters to make a decision is not always going to be possible, just based on the way our decisions need to be made and the way the world is working. It's too slow. So how do we make sure that we're giving that decision to the right level? And so it'll be interesting to see, as you were saying, with going from semi-autonomous to autonomous, how that again changes the human element of the equation as well.
Okay, thank you, Jamie.
So one comment when you said that the doctors are moving as fast as we can towards autonomy, I was reminded of the remark from Dr. Malcolm in Jurassic Park, where he says, your scientists were so concerned with figuring out whether or not they could, they didn't stop to think if they should. And so I do think there are profound questions about the creation of autonomous AI. I do think, like earlier this year, the Center for AI Safety, many of you may have seen, and it was a rather hyperbolic headline, but they did sign on to the proposition that AI could be as existential a problem as nuclear weapons and climate change. Was one of those two? And then having seen Oppenheimer this summer, there are many existential questions that I think we all need to contemplate and be cognizant of the technologies and ask whether or not we should, not only how we do it. So, yeah.
No, thank you for that. So, at the risk of throwing chum to sharks, I see a lot of industry folks here, and does anyone want to offer an opinion on whether the Navy is being forthcoming or opaque with what the Navy needs with unmanned or with AI and machine learning, or is it so crystal clear that you can go back to your companies and start making stuff? Anyone? Oh man, what a shy group. Okay, no worries. All right, Sandy's looking at his watch, so I think we've got time for a couple of more remarks. Maybe each one of you all close it out.
Your point is well taken, George, on the industry engagement. And as I exhorted in my remarks, if you're in the business of working unmanned systems, you need to know and understand your end users that are figuring out how to integrate that into the picture. Okay, I was a numbered fleet warfighter, ACOS, and I have a cartoon here that we couldn't show because George wouldn't let me show PowerPoint slides, but it's the king walking out to battle with his bow and arrow and spears, and his two staff assistants are like they've got a salesman in the back with a Gatling gun in the wagon, and the king says, "Well, I don't have time to talk to a salesman right now. I have a war to fight." That is our mentality on active duty. We're very, very focused on carrying out the plan of the day, and sometimes those days are long and the taskers just keep piling up. So I was very appreciative of my former sailors, soldiers, airmen, and Marines that I served with that were working for the Lockheed Martins of the world or the Northrop Grummans that would take the time to come in and update me on, we've got this technology that helps fill this gap that you've got. So if you're not knowing or comfortable with where you want to engage, get out there and talk to those guys and gals, because they've got tech gaps they got to fill.
Jamie?
Yeah, that was a great lead in, Neil, to talking about the warfare centers and what we have to offer as well. So yeah, we get a lot of industry coming to try to sell us the next version of the best AI out there, right? And that happens a lot, and we get tired of that. But what we do like a lot is collaboration and trying to figure out the problem and the solution together. And so there's a lot of really smart people working at the warfare centers across the country. And we have a lot to offer in terms of knowledge of the systems, the applications, the operators, how to test it, where, the people who have money even. We don't necessarily have the money to buy your products, but we can help build that together, right? Because we're not going to want to for you to just sell us something. It's almost as like, you don't know my data. You can't sell me that. Like, there's this sort of like, if you don't understand what's going into it, then you're not going to be able to provide me a solution. So working together with us, though, that really is the key. And so hopefully when, you approach people at the warfare centers, you have that mentality that this is a collaboration. We're all in it together to figure out the next greatest solution, because that's really the way, at least that I've experienced, works the best. So, yeah, I guess that's my takeaway.
Jeffrey, last words?
Indeed. So I think artificial intelligence is so interesting to me as an intellectual enterprise because it is this consilience of philosophy, technology, and what I love about OceanNet is that we can engage in basically high-level, almost academic, philosophical research, and yet then deploy in technology. So for instance, there was a book that George published a couple of years ago, AI at War, to which we contributed 2 chapters on the history of AI and the future of AI. And having a theory and understanding of what AI is, I think will be critical for everyone, including for the warfighter. And what I hope that we do is understand that the most important decision. So sometimes I think of AI research as in the context of the military as something of a Trojan horse, in that if we were to solve the true problem of designing a moral AI, you might find that a truly enlightened AI, like a truly enlightened human, might discover ways to render war obsolete. And so I think there's a truly transcendent goal that would it would be the ultimate, it'd be the ultimate goal realized. So
Jeffrey, we're not going to let you go unless you tell us about the Shakespearean tragedies and where you did what you did.
Oh, I prefer it to be a mystery.
Okay, even better.
Yes.
Well, please join me in thanking our panel, and we'll hang here for a while if you had any other questions.